So if I asked you at the beginning of this chapter when we were first starting it, and I introduced the 4 types of macromolecules, so the proteins, the nucleic acids, the carbohydrates, and the lipids, of those 4 macromolecules, which would you have thought was the most abundant on Earth? Proteins, nucleic acids, carbohydrates, or lipids? Well, as you might expect, because I'm asking this at the beginning of the carbohydrate section, yeah, it's carbohydrates. And if you looked at the next slide, you would have seen the first statement that it is the world's most abundant macromolecule. And the carbohydrates have a repeating unit, so they can be polymers made up of repeating units, which are called monosaccharides. So you take monosaccharides and you can join them up to make polymers. So if you have only one monosaccharide, like glucose, or 2 monosaccharides, making a disaccharide, such as lactose, or polysaccharides, such as cellulose. These are just 3 examples of a monosaccharide, a disaccharide, and a polysaccharide. Should you know on an exam if glucose is a monosaccharide or a disaccharide or a polysaccharide? Yeah, you should be able to tell me that you know that glucose is a monosaccharide versus lactose, disaccharide, cellulose is a polysaccharide. And I'll show you in the upcoming slides which ones I want you to know and which ones, okay. The functions of carbohydrates, there's so many different functions. The ones that would be most familiar to you are things like energy sources, but they can be sources of structures. And if you're writing on, if you're at a table, okay, it's probably made out of a carbohydrate. If you're writing on paper, you are writing on a carbohydrate. If you're wearing cotton, you are wearing a carbohydrate. So there's a great animation that introduces carbohydrates in your text. So carbohydrates can be either in a linear or cyclical form. So here's glucose, and you can see that it is a 6-carbon molecule, and it can be in this linear form or in this cyclical form. So carbohydrates can exist as monosaccharides, disaccharides, polysaccharides. Here's an example of 2 monosaccharides. And there's a bunch of different types of monosaccharides. They can vary in their carbon number or vary in the position of the carbonyl group or carbonyl group. So is this an aldehyde or a ketone? This is an aldehyde. And because it's a sugar, it would be considered an aldose. This type of carbonyl group is a keto group. Okay, so this would be fructose is an example of a ketose. Do I want you to be able to draw the structure of glucose or fructose or any of the other types of carbohydrates? No, you do not need to draw them. Do I want you to be able to recognize that this is a monosaccharide? Yes. Each of these are monosaccharides. Do I want you to be able to tell me if this is a glucose or a fructose? No. So you don't need to draw these. You don't need to know if this is a glucose or a fructose, but you should be able to say that this is a monosaccharide. So going back to comparing glucose and fructose, you'll notice that they both have the same molecular formula, but the arrangement of the atoms is different. Okay? And carbohydrates have the formula for every n number of carbons. You have twice as many hydrogens and n number of oxygens. So if it's a 5-carbon monosaccharide, it would be C5H10O5. And it's literally carbo, CH2O hydrate. So monosaccharides can be joined together to form disaccharides. And this is via dehydration synthesis, a type of condensation reaction. So here you have a glucose and a fructose, both of which are monosaccharides, and they can form the disaccharide sucrose. Okay? Again, would I want you to be able to draw the structure of sucrose? No. But would I want you to know that sucrose is a disaccharide? Yeah. Would I want you to know that sucrose is made up of glucose and fructose? Yes. So I would want you to know that glucose and fructose, when fused together, make sucrose. And I would want you to know that two glucose molecules make maltose, and lactose consists of glucose and galactose. And for those that have lactose intolerance, what causes people to have lactose intolerance? Well, lactose is a disaccharide where it's a fusion between glucose and galactose. And when the body is digesting lactose, it needs to break the bond that joins glucose and galactose. So the disaccharide during digestion needs to be broken down into the two monosaccharides. People with lactose intolerance have low levels, if any, of the enzyme that's necessary to break the bond between glucose and galactose. So this disaccharide can't be digested into the from a disaccharide to two monosaccharides in people with lactose intolerance because they lack the enzyme lactase. Polysaccharides are repeating units of monosaccharides. So polysaccharides are many monosaccharides that are joined together via dehydration synthesis. And so in plants, they can store polysaccharides in the form of starch. In humans, we have polysaccharides as a storage form of carbohydrate, and it's in the form of glycogen. So this is a polysaccharide. Each of these little six-membered rings is a monosaccharide joined together. Each of these is a monosaccharide joined together. So this is a type of polysaccharide. This is a type of polysaccharide. These are a type of polysaccharides. These are storage forms of carbohydrates in plants. These are a storage form of carbohydrate in animals. What's interesting is that the monomer that makes up the polymers for starch is glucose. So all of these are glucose. All of these are glucose. Okay? The monomer that makes up glycogen is also glucose. Okay? So these are all glucose molecules joined together. So this is glucose monomers joined together. This is glucose monomers joined together. This is glucose monomers joined together. The difference is in the branching. And the branching can make all the difference between the overall structure and whether it's a starch or a glycogen. But there's other types of polysaccharides. The one that you might be wearing or writing on or sitting at is the world's most abundant carbohydrate, and that is cellulose. And cellulose is also made of repeating glucose monomers. So all of these are also glucose, right? Joined together to form this other type of polysaccharide that's structural in form. So you can have glucose monomers joined together to make a polymer, forming cellulose, or forming starch, or forming glycogen. And the difference is how the carbohydrates are bound to each other. So we have three examples of the polysaccharides: starch, glycogen, cellulose. They all consist of repeating units of glucose. And how the glucose residues are joined to each other via glycosidic bond varies.